Alright, so here a woman purchases some 2 cent and some 15-cent stamps and pays $1.56 for all of these stamps. We are told that there are 10 more 2-cent stamps than 15-cent stamps. If X represents the number of stamps, what equation could be used to find the total number of stamps purchased? Okay, so before we even look at these equations, let's just break it down into some simple components, right? This problem might seem overwhelming, but just by breaking it into pieces, I think we can make some great developments. So at first it says that, right, we have 2-cent and 15-cent stamps, and that we pay $1.56. So I'm just going to glance down here and I notice that, okay, in every one of these equations we're using dollar amounts. So the dollar amount is $1.56, right? That's how much is being spent. And what would a 2-cent stamp be? Well, X is the number of stamps. So for 2-cent stamps, that would be 0.02, right? If you think about how we represent cents or pennies in general, if you would represent 2 cents, right, it would be 0.02, not 0.20 because that would be 20 cents, right? So here that's 2 cents and X is the number of stamps. So there's some number of 2-cent stamps and some number of 15-cent stamps, right? Some other number, Y. So if we add these up, we should get, right, $1.56. But notice, again, in all of these, there's only one variable, X. Why is that? Well, that's because of this piece of information right here. We know that there are 10 more 2-cent stamps than 15-cent stamps. So I'm going to go back and say that that the number of 2-cent stamps is based on the number of 15-cent stamps. And I'm going to use X as a variable. So I'm going to rewrite this saying, okay, there's some number of 15-cent stamps. And the number of 2-cent stamps is 10 more, right, than that. So whatever number of 15-cent stamps we now have that number X plus 10 more than X. That's the number of 2-cent stamps. And if we add them up, we spent $1.56. So this could be our equation. Let's just take a glance, right? Is that anywhere here? Well, I see it right here in D, right? They just wrote the order differently. They swapped the order of these two terms, but that's okay. We know by the commutative property of addition that the order of that doesn't matter. Notice they're saying again everything we said. There's some number of 15-cent stamps, and there's 10 more, right, than that for the 2-cent stamps. Add them up and we spend $1.56. And we could even solve this, right? 0.02 times X is 0.02X plus 0.02 times 10, right? Plus 0.15X is going to equal $1.56. So here 0.02 times 10, if we do that multiplication, what do we get? Well, we get, right, 0.2. You can think about 10 times 0.02 would make 0.02 10 times greater. So you get 20 cents, right? And then we can combine 0.02 and 0.15. We get 0.17 times X plus 0.2 equals $1.56. So now I'm going to simplify this, subtract 20 cents from both sides, subtract this 0.2. Running out of room though, sorry. And that's going to cancel this out. $1.56 minus 20 cents is $1.36, right? And that equals 0.17x. Now to simplify, we divide both sides by 0.17, so it's 1.36, divided by 0.17. And that makes sense because just as 136 divided by 17 is 8, 1.36 divided by 0.17 should be 8 as well. So that means that 8 is the number of stamps that we're buying, and X is 8. So I do all this because I like to test out my equations, right? I don't like to just blindly pick an equation. Sometimes my reasoning seems to make sense, but until you plug it in, you don't really know. So if we plug this in, if you have 8 15-cent stamps, how much is that? Well, 8 times 15 is what? That's just, well, 8 times 10 is 80. 8 times 5 is 40. That's 120 cents, or $1.20. How many 2-cent stamps are there? Well, we had 8 15-cent stamps, but there should be 10 more 2-cent stamps. So that means there's not 8 of them, but there's 18 2-cent stamps, and that's 36 more cents. So add that to $1.20, and you spend $1.56, which fits right into the problem. All right, thanks a lot.